we're going to have these exact type of questions on the quiz this week. Of course, I may ask you just to find the vertex, or just to find the axis symmetry, or just to find the y-intercept of the parabola. But there will be some questions where I actually ask you to graph it. And I even ask you to plot maybe 5 points, 3 points, or even up to 7 points of the parabola, right? So you have to go through the whole process of graphing. Step one on graphing is to find the vertex. The vertex is a coordinate. So to find the vertex, we use the vertex formula x equals negative b over 2 times a. And whenever you use this formula, I recommend to replace the b and the a with parentheses. And now you could actually look at your original quadratic trinomial equation and find your a value being 1, your b value being 10, and your c value you don't really care about because it's not in the formula. So let's plug in the b value of 10 and the a value of 1, and then you do the math, and you end up with negative 10 divided by 2. And negative 10 divided by 2 is really a negative 5. So we just found the vertex x value. It says x equals. So x equals negative 5, and that is a vertex x value. The x value is negative 5. Okay. How do we find the y value? You simply plug it in. Okay. So plug it in. Now, what do I mean by that? I want to plug in this negative 5, the x value of negative 5. I want to plug it in right into the x's. So I want to take both of these x's, put parentheses, and then plug in that negative 5 right into those x's. So here's the equation with parentheses instead of x's. And we are plugging in the value of negative 5 right in there. So negative 5 is the x, negative 5 is the x. So you plug them in. Now you could work it out. You could either plug this whole thing and type it in exactly the way you see it in a calculator, or you could work it out the way I'm about to right now. You always start with parentheses, but there's nothing to do in the parentheses. You just plugged in the value of negative 5, but then you move on to e exponents, and you have negative 5 squared. That's negative 5 times negative 5. That's positive 25. And then we have this positive 10 times negative 5. That's negative 50, or a minus 50. And then you bring down the plus 16 right here. So you have a plus 16. And if you go from left to right, 25 take away 50, that's negative 25. I might as well write that down, negative 25. And then bring down the plus 16. Negative 25 plus 16 is negative 9. So our y value equals negative 9. Okay, so our y value is negative 9. That is the y value of the vertex. So that's why I have my y value being negative 9. So my vertex is negative 5, negative 9. So on Quizizz, you do all this, you show all this work on your paper. Then once you know that your vertex, the most important point, negative 5, negative 9, you plot that point on the graph. So you're able to put any dot you want anywhere on the graph. So negative 5 on the x, negative 9 on the y, and that would be right here. And you leave that dot right there, okay? And then you need more points. So you could go to an input-output table, to an XY table, but that technically is a waste of time. Why? Because if you know that your A value is 1, you could use the pattern, 1, 1, 2, 4, 3, 9. So when A equals 1, you can use 1, 1, 2, 4, 3, 9. Now, this is a pattern from the vertex, wherever that vertex is, and we know the vertex is right here. So because the A value is 1, you could use 1, 1, 2, 4, 3, 9. Even if the A value were 2 or 3 or even 1/2, you could still use it, but you have to modify the outputs, the 1, 4, and 9. You have to multiply those by whatever your different A value is. But if your A value is 1, you could use 1, 1, 2, 4, 3, 9, and let's do that exactly. I want to demonstrate how to use that pattern in case you haven't learned yet. From the vertex, you're going to go 1, 1. That's not a coordinate, but it is a pattern from the vertex. That means 1 over, 1 up. And it doesn't mean it doesn't matter if you go over to the right or to the left. Just go 1 over to the side and 1 up and put a dot right there. So again, you're gonna plot one of these points, 1 over, 1 up right there. And then you go back to the vertex and you're gonna go 2 over, 2 to the side, 4 up. So 1, 2 to the side, and 1, 2, 3, 4 up, and you're going to put a dot right there. So again, you're going to plot one of these dots. So that was 1, 2, 1, 2, 3, 4 right there. And last but not least, 3 over 9 up. So I might as well grab one of these and go 3 over 9 up from the vertex 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9 right there, and it's on the x-axis. So that, as you could see, is half a parabola. We could map them over to the other side of the axis of symmetry. So you're going to imagine that there's that green dotted line that I normally do, the axis of symmetry that runs right through the vertex. So just map it over to the other side. Right here, it's 1 unit away, so go 1 unit this way, and you'll have that dot right there. And then the other one is 2 units away from the axis of symmetry, right? So 2 units, so go 2 units this way, and your dot will be right there. And last but not least, take that last point, and this one is 1, 2, 3 units away from the axis of symmetry, so 1, 2, 3 units away this way, and there's your parabola. Those are all your dots. You hit submit, that's how you get full credit. So you have to have all these 7 points plotted correctly on the XY plane to produce this perfect parabola. Make sense? Cool. So what happens when your A value is not 1? Let's take a look at this one right here. So, once again, we always begin with the vertex, which is a coordinate, right? And to find the coordinate, you got to use the formula, and the formula for the vertex is x equals negative b over 2a. And when you use the formula, I highly recommend that you rewrite the formula, but instead of negative b, put negative parenthesis. Instead of over 2 times a, put over 2 times parenthesis. Then you could identify the b value being negative 12, and the a value being negative 2, okay? The c value, it's not even in the formula, so who cares? But anyways, just plug in the negative 12 right into the b spot, and the negative 2 right into the a spot. So what we have here is a negative 12, which becomes positive 12, over 2 times negative 2 is negative 4. And last but not least, 12 divided by a negative 4 is a negative 3. So we just found the x value of the vertex being negative 3. So the x value is negative 3 of the vertex. Now you want the y value. Anytime you have an x and you want the y, you just rewrite this quadratic trinomial equation. But instead of x's, you see we already know that x is negative 3. So instead of these x's, I'm going to put parentheses. Then I'm going to plug in the negative 3 into those x's. So let me begin by rewriting it, but instead of x's, I'm going to put parentheses. There it is, y equals negative 2x squared minus 12x minus 11. And yes, I put parentheses instead of x's because I already know my x is negative 3. So I'm going to substitute the negative 3 right into those parentheses. A negative 3 right there and a negative 3 right there. And of course, you could type all this into a calculator exactly the way it looks, and it'll give you the precise y value, the precise answer, the y value of your vertex, or you could work it out the way I'm about to right now. Let's begin with exponents. Negative 3 to the second power, negative 3 times negative 3 is positive 9. Then you could bring down the multiplication of negative 2, and what is negative 2 times a positive 9? That is a negative 18, okay? Then we could call this a negative 12 times a negative 3. That'll be a positive 36, so put a plus 36 down here right next to the negative 18, and also bring down that minus 11. So now it's just adding and subtracting from left to right. A negative 18 plus 36, that is a positive 18. And positive 18 take away 11, if you bring down the minus 11, that'll give you a 7. So we just found that y equals 7. We'll write that out, y equals 7. Now, what is this y? It's the y of the vertex, right? We originally found the x, now we found the y by plugging in the x, and the y is right here. So negative 3, positive 7 is the vertex. That is the most important point. So you do all this work on your paper. Of course, you have to turn it in. If you don't have this work, you don't get credit, right? Even though you might graph the correct answer, If I don't see the correct work, you can't get credit. So you are turning in the work. Let's go to the location -3, 7. Remember, this is your x, this is your y. Here's the x-axis, here's the y-axis. So you're going to go to the location -3 on the x and +7 on the y. So you just plot a point at -1, 2, 3, 1, 2, 3, 4, 5, 6, 7, right there. That's your most important point. You could imagine an axis of symmetry running right through it. And now let's plot some more points. So you could use an input-output table, but I don't recommend it, right? What I recommend is to use a pattern. Now, we know we could use a pattern 1, 1, 2, 4, 3, 9 when the A value is 1. But if your A value is something different, like we could clearly see right here that the A value is -2. So we're going to have to modify this pattern by taking the outputs, right? These are the inputs, these are the outputs. You need to take the outputs and multiply them all by the new A value of -2. So you're going to multiply the 1 times -2. You're going to multiply the 4 times -2, multiply the 9 times -2. And it'll give you your new modified pattern, okay? So what will I get? 1 times -2, that's -2. 4 times -2, that's -8. 9 times -2 is -18. So the new pattern is 1 over from the vertex, 2 down. Then you go back to the vertex, 1 over, 2 down, put a dot there. And then you go back to the vertex, 2 over, right? 2 over, and the modified output, 8 down. So you're going to go 2 over, 8 down, okay? And then you're going to go to the last modified pattern, 3 over and 18 down. I don't even know if they're all going to fit. As a matter of fact, they only asked for 5 points. So we're probably not even going to use this last one. So let's go with this first point, and let's use the first part of the pattern. The first part of the pattern is 1 over, 2 down. 1 over, 1, 2 down, and you put a dot right there. And the next one, from the vertex, you go 2 over, 8 down. 1, 2 over, 1, 2, 3, 4, 5, 6, 7, 8 down right there. And again, I'm doing 1 over, 2 down, 2 over, 8 down from the vertex. Then I would go 3 over, 18 down, but even if I tried that, 1, 2, 3 over, 18 downs off this graph, so obviously you're not going to use that last part of the pattern, but you could map the points over to the other side of the axis of symmetry. So you don't have it drawn, but you could imagine this axis of symmetry line that passes right through the vertex, and you could map it over to the other side. You could take this point, which is 1 unit away, and go 1 unit this way and plot the point right there. You could do the same with this next one that's 2 units away and go 2 units this way and plot the point right there. Submit your answer. That's your parabola, right? I mean, if you were graphing on paper, you would actually draw your parabola, but you're not able to draw it right here. You just plot those 5 points, 1, 2, 3, 4, 5, hit submit, you get full credit. What do you think? Got it? Any questions? No? So on this one again, you begin by finding the vertex. Let's actually start by finding the vertex, which is a coordinate, an x value and a y value. And you find the x value using the formula, x equals -b over 2 times a. And like always, whenever you use the formula, please replace your b and your a with parentheses. Then identify the b value and the a value, and then plug them in. The c value is -2, but c is not in the formula. So plug in your b value of -12 into that top parenthesis, and plug in the a value of -3 into that bottom parenthesis. Then you work it out, and of course, -12 becomes +12, and 2 times -3 becomes -6. And if you do 12 divided by -6, that'll be a -2. So the vertex x value is -2, right? X equals -2. So that's the vertex x value. That's the x. Now you still need the y. So whenever you have an x, see, these are x's right here. Whenever you have the actual value of x, just plug them in, and you'll be able to find the answer for y. Okay? So we're going to plug them in by safely rewriting the original equation. Y equals -3x squared minus 12x minus 2. Now you're thinking, wait a minute, he wrote parentheses instead of x's. That's absolutely right. Whenever I plug in my x value, I want to plug it in with parentheses. So the x value is negative 2. So you plug in the x values of negative 2 into the parentheses where the x's used to be at. And then you do the math. Start with exponents. Negative 2 squared. Negative 2 times negative 2 is positive 4. Multiply it by the negative 3 out in front. That'll be a negative 12. Okay? And then negative 12 times a negative 2, that's a positive 24. Just wrote it a little bit down here, so it'll be right next to the negative 12. Bring down that minus 2 as well. And then go from left to right. Negative 12 plus 24, that's a positive 12. And 12, bring down the minus 2. 12 minus 2 is 10. So we just found that y equals 10. Y equals 10. That's what we found. And that is the y value, that is the y value of the vertex, which is positive 10, y value. So this is the most important point. It's the maximum value because the parabola is opening down. So let's go to that most important maximum value point, negative 2 on the x, positive 10 on the y. Remember, this is your x-axis, this is your y-axis. Negative 2 on the x, positive 10 on the y. Put a dot right there. And then we know that there's an axis of symmetry that runs right down through it, and we need more points. And you could go, if you wanted to XY table, but that is a waste of time. What I would do is use the pattern 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. However, you need to modify it because it has a value of negative 3. And this pattern is for the a value of 1. But if you have the a value of negative 3, all you have to do is multiply the outputs, the 1, the 4, and the 9, multiply them by that new a value of negative 3. So you're going to multiply the 1 times negative 3, the 4 times the a value of negative 3, and the 9 times the a value of negative 3. And you're probably not even going to use this whole pattern, but let's modify it. 1 times negative 3 is negative 3. 4 times negative 3 is negative 12. 9 times negative 3 is negative 27. So you're using the pattern 1 over and negative 3 down, or 3 down. And then 2 over and then negative 12, or 12 down. And then 3 over and 27 down, which you're not even going to be able to go 27 down on this graph. So from the vertex, let's go 1 over 3 down. So I want to get one of these points from the vertex, 1 over 1, 2, 3 down, and put a dot right there. Then I go back to the vertex, and I go 2 over 12 down. So from the vertex, I go 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And of course, we do have an axis of symmetry that you really can't see, but you know it's. I mean, if you could draw it, you could draw it like this. It goes right through your vertex, the vertical line right through your vertex. By the way, if I asked you what equation is the axis of symmetry, you would say x equals the x value of your vertex, which would be negative 2. But you're going to use that axis of symmetry line to reflect your points to the other side with that same distance. So you're going to take a point and go 1 unit away, put a dot right there. You're going to take another point, and you're going to go 2 units away and 2 units away and put a dot right there. Hit submit, and you have your answer, right? Obviously, if you were graphing on paper, you would actually draw your parabola right through those points, and it's with arrows, right? And just for kicks here, if I asked you for the domain of this parabola, it would be domain equals x equals all real numbers. If I asked you for the range of your y values, that would be y is less than or equal to 10, the y value of your vertex.